Hey there, in this video we're going to learn how to use arrays. Arrays are really handy for us. They're kind of like a vector in physics, so you can have multiple components in the same object, or an array can actually be a long list of anything, a long list of x values, a long list of y values. And what they do is they let us very quickly repeat a calculation point by point or value by value without having to use something like a for loop or a while loop. To get access to arrays, we need to import the Numpy package. So we'll use an import statement here. And since Numpy is used so frequently, we're going to use a shorter name for it. We're going to rename it NP. And that's actually very common. If you look up basically any kind of scientific code, you're going to see Numpy is being used, and they're going to have renamed it as NP. So we'll follow that convention as well. Let's go check out our contextual help. It's going to show us some information about Numpy here. And you might want to read through this on your own. For now, we just want to look at the most basic feature, which is arrays. If it says anything about arrays in here. Well, no matter. I'll show you. First of all, let's look at why we even need to import something new. Why can't we just use Python's lists? So let's say I have two lists. Let's make the first one 1, 2, 3, 4, 5. And I'll make a second list equal to 5, 6, 7, 8, 9. And let's say I want to do some kind of calculation with these lists. I want to add them up element by element. So I want to create a third list whose first element is 1 plus 5, second element is 2 plus 6, and so on down the list. Unfortunately, that is not going to be just a plus in regular Python. If I run that command, what happens instead is Python interprets addition of lists as concatenation of the lists. It doesn't know how to handle them element by element. It is true we could write some kind of for loop that would go through a set of indices and then add them up. But as it happens, that would actually be really kind of slow. Doing any kind of loop operation in Python is a fairly slow thing. And there is a much better way to do this, which is using an array out of NumPy. So to create an array, what we're going to do here is from the NumPy package, we're going to call a function named array, which creates an array for us. And we're going to feed it some kind of sequence. So we can give it a list. We can make an array right out of a literal list 1, 2, 3, 4, 5. And we could do this a second time for array 2. NumPy.array. Let's make them the same. So this will be 5, 6, 7, 8, 9. Now let's look at what happens if I add these together. A1 plus A2 is equal to the two arrays added element by element. So the reason we have, or we want to use arrays, is they have a different behavior than lists, number one. And number two, they are written with the intent of being very fast, whereas NumPy lists are written with the intent of being very generic. But we can do some other stuff with arrays, like we can use math functions. NumPy has quite a lot of stuff in it. If I do numpy.tab a few times, and take a moment here to load up everything in it. There we go. We can see we have all these functions, some of which are like trig functions or math functions. So let's say I want to do the square root. If I check here, where's there a lot of stuff? Okay, square root, right? Squirt. So we could do a square root from NumPy. So NumPy square root of A1. And what that'll do is it'll go through and it'll take the square root of the array element by element. They could do this very quickly because of the way the arrays are programmed behind the scenes. It's not quite parallel that it does each of these steps, but it is so fast that you can sort of conceptualize it as being a parallel operation, that it just all at once changes everything in the array. The arrays themselves have some methods attached to them, just like lists have methods attached to them. If we hit a1.tab, we can see some of those methods. A couple that might come in handy are mean, as in the average, and standard deviation, right here. So if I want to calculate the average value, I can do a1.mean, and the average value of 1, 2, 3, 4, 5 is going to be 3. Okay, so in this video we introduced arrays and we looked quickly at how we can add arrays together. We could also multiply the arrays, divide the arrays, and any operation we do on the arrays will be element by element. There are some functions built into the NumPy package that will work on arrays and basically transform the entire array all at once. And arrays have some methods attached to them for our purposes, the ones we'll be using most often will be like, say, mean and standard deviation to quickly do a little bit of statistics on our array.